On a quiet night in July 2025, humanity's tireless watch over the heavens paid off once more. Telescopes, ever vigilant, scanned the cosmic ocean for anything out of the ordinary. In this vast darkness, a faint point of light was flagged, a traveler moving on a path that was distinctly not our own. This discovery was made by two powerful systems working in concert: NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, and the Deep Random Survey's remote telescope nestled in the high deserts of Chile. Together, they spotted an object on a trajectory that could only mean one thing. It had come from far, far beyond the gravitational embrace of our sun. This was not just another rock tumbling through the familiar orbits of our solar system. Its path was a giveaway, a trajectory so extreme, so hyperbolic, that it betrayed an origin in the vast, star-strewn expanse between solar systems. The Minor Planet Center, the official record keeper for these celestial encounters, swiftly gave it a designation 3I Atlas. The 3I was significant. It marked this object as only the third interstellar visitor ever confirmed to have entered our cosmic neighborhood. It followed in the footsteps of the enigmatic 1I Oumuamua and the more conventional 2I Borisov. Yet it promised to be a mystery all its own, a new page in our ever-expanding book of the cosmos. Imagine our solar system as a serene, self-contained island in a vast, churning sea. For centuries we believed we were isolated, that the only objects we would ever encounter were those born here with us. But the discovery of interstellar objects shattered that illusion. These visitors are like messages in a bottle, cast into the cosmic currents from distant, unknown shores. They are physical relics from other star systems, offering us a chance to touch, or at least observe matter forged in an environment completely alien to our own. The arrival of 3I Atlas was another such opportunity, a rare chance to study a piece of another world without leaving our own. The announcement sent ripples of excitement through the astronomical community. Every new interstellar object is a cause for celebration and intense study, a fleeting chance to learn something new about the galaxy we inhabit. What secrets did this traveler carry? Was it a comet, an asteroid, or something else entirely? As observatories around the world turned their powerful eyes toward this distant speck of light, the quest to understand 3I Atlas began. Its journey into our solar system was just starting, but our own journey of discovery was already underway, promising to challenge our understanding of what wanders through the great silent darkness between the stars. As scientists began to gather data on 3I Atlas, its portrait started to take shape, and what a strange portrait it was. The first and most staggering detail was its sheer size. Initial estimates placed its diameter at approximately 20 kilometers, or just over 12 miles. This was no mere cosmic pebble. It was a veritable mountain hurtling through space. To put this into perspective, 3I Atlas was significantly larger than both of its interstellar predecessors combined. It was a giant, a behemoth from another star system, making it by far the largest interstellar object ever recorded. Its immense scale alone made it an object of profound scientific interest and a puzzle to be solved. Beyond its size, another feature, or rather a lack thereof, baffled observers. Given its icy composition, which was inferred from its distant origins, astronomers expected 3I Atlas to behave like a comet. As comets approach the sun, its warmth causes their ice to sublimate, turning directly into gas. This process creates a glowing coma or atmosphere around the nucleus and a magnificent tail of gas and dust that can stretch for millions of miles. Yet, as 3I Atlas drew nearer, it displayed no such cometary activity. There was no tail, no dramatic outgassing visible to our telescopes. It remained a stark, solitary point of light against the black canvas of space. This lack of a cometary tail was a significant clue, but it deepened the mystery rather than solving it. Why would such a large, presumably ice-rich body from the cold depths of interstellar space not react to the sun's warmth? One possibility was that it possessed an unusual surface crust, a protective layer that insulated its volatile ices from the sun's energy. Perhaps its long journey had weathered it in a way we had never seen before. Another idea was that its composition was fundamentally different from the comets born in our own solar system. Whatever the reason, its stoic silence was as intriguing as a brilliant tale would have been. While it lacked a classic tail, closer inspection revealed something subtle and strange. Observations from the powerful Gemini North Telescope in Hawaii detected a very small, compact cloud of gas and dust huddled closely around its core. It wasn't the sprawling coma of a typical comet, but it was something. This suggested that some activity was occurring, but it was suppressed, muted, and unlike the predictable behavior of our local comets. 3I Atlas was not a simple asteroid, nor was it a classic comet. It was something in between, a hybrid object that defied our neat classifications and challenged our assumptions about what to expect from these interstellar travelers. The puzzles presented by 3I Atlas did not end with its size or its missing tail. As the world's most powerful observatories focused their gaze, the Hubble Space Telescope captured an image that would become the object's defining mystery. On July 21, 2025, when the visitor was still a distant 277 million miles from Earth, Hubble revealed something utterly unprecedented. There, in the blackness of space, was a faint but distinct glow. The truly bizarre part was its location. The glow appeared in front of 3I Atlas, preceding it on its journey toward the sun. This was not a phenomenon anyone had ever seen or predicted. Comets glow from behind. Their tails are pushed away from the sun by the solar wind and radiation pressure, always pointing away from our star. An asteroid, a simple inert rock, would have no glow at all. But a glow in front of the object? It defied the known physics of our solar system. It was as if 3I Atlas was projecting a soft lantern light ahead of it as it moved through the darkness. The scientific community was stumped. What could possibly cause such an anomaly? The data was clear, the image was unmistakable, but the explanation was completely absent from our astronomical textbooks. Speculation began immediately, with scientists proposing a range of naturalistic, albeit exotic, possibilities. Could there be a cloud of fine dust particles traveling ahead of the main body, catching the sunlight in a peculiar way? This would be unusual, as such particles should have been dispersed long ago. Another idea involved a strange interaction between the object and the solar wind, the stream of charged particles flowing from the sun. Perhaps 3I Atlas had a unique magnetic field or composition that caused plasma to build up in front of it, creating the observed luminescence. Each theory was more complex and less certain than the last. This mysterious forward glow became the central enigma of 3I Atlas. It was a feature that separated it not only from every comet and asteroid in our own solar system, but also from the previous interstellar visitors. Oumuamua had been strange for its shape and acceleration, but this was different. This was an active phenomenon that seemed to violate the basic principles of how objects interact with their environment in space. It was a stark reminder of how much we still have to learn, a cosmic curveball thrown from the depths of the galaxy, forcing us to question our most fundamental understandings of celestial mechanics. The path of 3I Atlas through our cosmic home was as remarkable as its physical properties. Its trajectory was a lesson in celestial mechanics, a high-speed tour of the inner solar system that brought it unusually close to several planets. The object was traveling on a retrograde orbit, meaning it was moving in the opposite direction to the planets. This is a classic hallmark of an interstellar visitor, as objects born within our solar system almost universally orbit the sun in the same direction, a remnant of the spin of the protoplanetary disk from which they formed. 3I Atlas was a celestial salmon swimming against the current. Its orbit was also nearly aligned with the ecliptic, the plane on which the planets travel. This alignment made its journey particularly interesting, as it set the stage for a series of close encounters. 3I Atlas wasn't just passing through the distant, empty regions of our solar system, it was plunging right into the heart of the action. Its trajectory brought it on flyby courses with Mars, Venus, and even the colossal king of planets, Jupiter. Each of these encounters provided a unique opportunity for the object to be gravitationally nudged and for us to study how this alien traveler interacted with the various environments of our planetary neighbors. These close passes were a gift to planetary scientists, but they also posed a challenge. As 3I Atlas prepared for its closest approach to Earth in December 2025, it would be a distant 270 million kilometers away, posing absolutely no threat to our planet. However, a cruel twist of celestial alignment meant that at that precise moment, Earth would be on the opposite side of the sun. This positioning would make direct observation from Earth-based telescopes impossible, blinding us at the moment of its nearest passage. Our best views would come before and after this period, leaving a critical gap in our data during a time of potentially high activity. The visitor's closest approach to the Sun, its perihelion, would occur at a distance of 210 million kilometers. This is farther out than Earth's orbit, but still deep enough within the solar system to receive significant solar radiation. This journey, a retrograde plunge, a series of planetary flybys, and a frustratingly timed alignment with Earth, made the observation campaign for 3I Atlas a complex and dynamic puzzle. Scientists had to seize every available moment, knowing that this mysterious guest from another star would not linger. It was on a one-way trip, destined to loop around our Sun and be flung back out into the interstellar darkness forever. Where did this colossal, enigmatic object come from? Tracing its path backward, out of our solar system and into the galaxy, astronomers began to piece together a possible origin story. The trajectory of 3I Atlas suggested it was not from one of our nearby stellar neighbors. Instead, its path pointed toward a more ancient and distant part of our galaxy. The evidence indicated that it might have originated in the outer, thicker disk of the Milky Way. This is a region populated by older stars, a part of the galaxy that has been around for a very, very long time. If this origin story is correct, it would make 3I Atlas not just an interstellar object, but a true cosmic fossil. Comets are often called dirty snowballs, but they are more accurately time capsules. They are pristine remnants from the formation of planetary systems, their icy bodies preserving the chemical makeup of the nebula from which they were born. A comet from our own Oort cloud is a relic from the birth of our solar system, about 4.6 billion years ago. But a comet from the thick disk of the Milky Way could be far, far older, potentially originating from a star system that formed billions of years before our Sun even ignited. This possibility is, honestly, staggering. It means that 3I Atlas could be the oldest comet humanity has ever had the chance to study. Its composition could hold clues not just about the formation of another solar system, but about the chemical conditions of the galaxy in a much earlier epoch. By analyzing the faint cloud of gas around its nucleus, scientists could look for chemical signatures or isotopes that are different from those found in our own system. This would be like, an archaeologist finding a tool from a previously unknown and ancient civilization, offering a direct physical link to the deep past of our galactic home. The ejection of such an object from its home system is a violent process. It was likely flung into the interstellar void by the gravitational influence of a giant planet, similar to how Jupiter and Saturn sculpted our own solar system and sent countless comets out to the Oort cloud. For billions of years, 3I Atlas would have drifted silently and alone through the cold, empty space between stars. It was a solitary wanderer on an unimaginable timescale, a silent messenger carrying ancient secrets. Its chance encounter with our solar system was a 1 in a trillion event, a brief intersection of its epic journey with our own. As the scientific community grappled with the natural explanations for 3I Atlas, a far more provocative idea emerged from the mind of one of astronomy's most audacious thinkers. Avi Loeb, a theoretical physicist from Harvard University, looked at the growing list of anomalies associated with 3I Atlas and proposed a hypothesis that was both thrilling and controversial. In a paper co-authored with Adam Hibbard and Adam Crowell, Loeb suggested that we should consider the possibility that 3I Atlas is not a natural object at all. He argued that it might be an artifact of an extraterrestrial intelligence, an alien probe sent by design. This was not the first time Loeb had ventured into such territory. He famously made a similar claim about Oumuamua in 2017, arguing that its unusual acceleration could be explained if it were a thin, light sail-like craft. Now, with 3I Atlas, he saw a new set of clues pointing in the same extraordinary direction. For Loeb, the starting point was the object's immense size and the seeming frequency of these interstellar visitors. He argued that based on our understanding of planetary formation, there simply shouldn't be enough rock and ice drifting between stars to account for an object of this magnitude arriving in our solar system once per decade. Loeb's calculations suggested that an event like the arrival of 3I Atlas should be exceptionally rare, perhaps happening only once every 10,000 years. To have it happen so soon after Oumuamua and Borisov was, in his view, statistically improbable if we only consider natural origins. This statistical argument formed the foundation of his hypothesis. If nature couldn't produce these visitors this frequently, then perhaps something else was at play. Perhaps these objects weren't random debris, but were instead directed, targeted, or part of a systematic exploration of the galaxy by another civilization. The idea, of course, lands squarely in the realm of science fiction for many, but Loeb insists on treating it as a serious scientific hypothesis. He argues that we must be open to all possibilities, especially when faced with phenomena that defy easy explanation. The core of his philosophy is that to dismiss the possibility of alien technology out of hand is unscientific. Instead, we should follow the evidence where it leads, even if it takes us to uncomfortable or extraordinary conclusions. The whisper of alien technology, however faint, was now officially part of the scientific conversation surrounding 3I Atlas. Avi Loeb and his collaborators built their case for an artificial origin on more than just statistics. They pointed directly to the most baffling feature of 3I Atlas, the mysterious glow in front of it. A comet wouldn't have glow in front of it, Loeb stated bluntly. In the absence of a plausible natural explanation, he offered an artificial one. Perhaps the glow is not a natural phenomenon at all, but rather a byproduct of a technological process. Could it be some form of venting, an energy signature from a propulsion system, or a shield designed to protect the probe from interstellar dust at high speeds? The timing of the object's closest approach also fueled Loeb's speculation. The fact that 3I Atlas would be unobservable from Earth during its nearest pass to our planet struck him as suspiciously convenient. He noted that this period of invisibility would be the perfect time for it to maneuver. If it were a probe, this would be the ideal moment to deploy a smaller craft, change its trajectory, or perform some other action without being watched. While this is an argument from a lack of evidence, it highlights how unexplained circumstances can be interpreted in very different ways, depending on one's starting assumptions. Loeb also connected his hypothesis to a darker, more speculative concept known as the dark forest hypothesis. This idea, popularized by science fiction author Cixin Liu, suggests that the universe might be filled with intelligent life, but civilizations remain silent and hidden for fear of being destroyed by others. In this scenario, a probe like 3I Atlas could be a scout from a cautious and potentially dangerous civilization. Loeb warned that we must take the possibility seriously, stating, "3I Atlas may come to save us or destroy us." He stressed the urgent need to scrutinize every interstellar object that enters our system. Ultimately, Loeb's case rests on the principle that when faced with multiple anomalies, the large size, the statistical rarity, the lack of a tail, and the unprecedented forward glow, the hypothesis of an artificial origin deserves to be on the table. It is a classic application of the Sherlock Holmes maxim, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. For Loeb, the natural explanations were beginning to look increasingly strained, while the improbable hypothesis of an alien probe seemed to fit the strange collection of facts in a compelling, if unsettling way. The scientific community's reaction to Avi Loeb's bold hypothesis was, predictably, divided. It ignited a fierce debate that played out in scientific journals, online forums, and academic conferences. On one side stood a majority of astronomers and astrophysicists who urged caution and skepticism. They argued that while 3I Atlas is undoubtedly a strange and fascinating object, proposing an alien origin at this stage is a leap too far. The history of science is filled with mysteries that initially seemed inexplicable, but were eventually solved by natural explanations we simply hadn't discovered yet. These critics pointed out that the bar for an extraordinary claim like it's aliens must be extraordinarily high. Before we can entertain the idea of an artificial probe, every single possible natural explanation must be rigorously tested and definitively ruled out. Many accused Loeb of engaging in sensationalism, of jumping to a headline-grabbing conclusion without sufficient evidence. They argued that his statistical claims about the rarity of such objects are based on models that are still incomplete. We have only been systematically searching for these objects for a short time, so our understanding of their true population in the galaxy is still very uncertain. However, not everyone in the scientific community was so quick to dismiss Loeb's ideas. Another camp, while not necessarily endorsing the alien probe theory, saw value in the debate itself. They viewed Loeb's hypothesis as a pedagogical exercise, a useful thought experiment that forces the scientific community to confront a profound question. How would we actually identify an alien artifact if we saw one? By taking the possibility seriously, we can begin to develop protocols and methods for analyzing future discoveries, preparing ourselves for a day when the evidence might be less ambiguous. This debate highlights a healthy, if sometimes contentious, tension within science. It is a push and pull between the cautious, methodical accumulation of evidence and the bold, imaginative leaps of hypothesis. Both are essential for progress. The skeptics ensure that our understanding is built on a firm foundation of proof, while the provocateurs like Loeb push the boundaries of our thinking and force us to ask bigger questions. The controversy surrounding 3I Atlas is not just about one object, it's about the very nature of scientific inquiry and how we confront the unknown. Regardless of its true nature, 3I Atlas has already taught us invaluable lessons. It has shown us that the population of interstellar objects is more diverse and strange than we could have imagined. It has challenged our neat categories of comets and asteroids, revealing that nature is always more complex and creative than our models. The study of this single object has pushed our observational technologies to their limits and sparked new theoretical work to explain its bizarre behavior. It is a powerful reminder that there is a vast, unexplored universe out there, filled with wonders we have yet to even conceive of. The arrival of 3I Atlas, following so closely on the heels of Oumuamua and Borisov, signals the dawn of a new era in astronomy, the era of interstellar studies. We are no longer limited to studying our own cosmic backyard. We are now able to analyze physical samples from other star systems as they pass through our own. This field is poised for explosive growth. The Vera C. Rubin Observatory, set to begin its legacy survey of space and time, is expected to discover not just one or two, but potentially dozens of interstellar objects every year. We are on the cusp of having a steady stream of these cosmic messengers to study. This coming flood of data will transform the debate. With a larger sample size, we will be able to determine if objects like Oumuamua and 3I Atlas are truly rare anomalies, or if they represent common classes of objects in the galaxy. We will be able to build a much better understanding of their origins, compositions, and behaviors. The hypotheses proposed by figures like Avi Loeb will be put to the test. If most new interstellar objects look like the conventional comet 2I Borisov, his arguments will weaken. If we find more strange objects with inexplicable features, his ideas will gain more traction. Ultimately, the story of 3I Atlas is a story about our own place in the cosmos. It is a story of curiosity, of our innate human desire to look up at the sky and ask, what's out there? Whether it is a natural relic from the dawn of the galaxy or a piece of advanced technology from a distant civilization, its journey through our solar system is a profound gift. It expands our horizons, fuels our imagination, and pushes us to continue our relentless search for answers. The universe has sent us a puzzle, and in our quest to solve it, we will inevitably learn more about the cosmos and, in turn, more about ourselves.